that about 25% of the Earth's crust formed somewhere between about 2 billion and 1.8 billion years ago. You can see a massive peak of gold, nothing in between, effectively, this massive peak of gold in here. About 1.2 billion years ago, we had a lot of action, a lot of crustal formation. We don't see any gold. Now, to explain this is very complicated. It's to do with the lithosphere, but I suspect that this is a time. So here we have big, thick lithosphere. These big plumes produce really thick lithospheric keels under the continents. These were very stable. Here we stopped having so much plume activity, a little bit of plume. We had really what we see today as modern plate tectonics without much plumes. This produces very thin lithosphere. So this might be 250 kilometres deep. This might be 150 kilometres deep. By the time we get out here, we're probably looking at 60 kilometres deep. So a massive difference. And these are very buoyant. They sort of float on the mantle. These are not. They sink into the mantle. So I think when we see that, we don't see any. The gold deposits almost certainly formed. We know of some, but they got eroded away because the mountain belts got eroded right down to their roots. And then in the Phanerozoic, so we see your gold deposits are occurring around here. So it's a good time for gold as well around the world. And then we see this sort of periodic, every time there's an orogeny, these are the main orogenic periods, every time we get an orogeny, we're getting gold. One of the troubles is we can't date the gold so accurately, so we can't correlate it back to that. What's the scale of all this? Again, scale is important. This is part of Eastern Australia. It's 100 kilometres, so we've got something like 1,000 kilometres across here. And although there are two ages of gold, most of the gold formed about 440 million years ago. This is a cross-section across the belt, not along the belt. So we're seeing gold forming over the whole of the orogenic belt. And interestingly, some other mineralisations and porphyries and so on is occurring exactly the same time way over here, and something else is occurring, some lead zinc is occurring over here, exactly the same time. So this has to be something right across the lithosphere and the crust. Another important thing of the gold deposits is that they occur where we're getting changes in motion. So in North America, we're very lucky that there's an awful lot of tectonic. The journal Geology was set up by the Geological Society of America just really for tectonics. So here we see the subduction was about 90 degrees to the coast, and then at about 55 million years ago it changed and it became oblique to the coast. So all the thrusts that were forming here got reactivated into strike slip here. It's work from a guy called Rich Goldfarb. He dated all the deposits. Again, you can see this is something like 300-400 kilometres long down the belt, all essentially within error, given that they were all done with different techniques and all related to that. So he published this work in the mid-90s, and everywhere we've worked with students, we've found that always the gold is occurring at a change from compression to transpression, where we're getting this sort of motion. So we're just getting head-on thrusting, we're getting some strike slip component into the faults, and the gold, you see, over, there's probably 400 kilometres, maybe more, we're getting gold at the same time. We go back to the section, we can see this is across, so that's down the belt, this is across the belt, we're seeing gold at essentially the same time. So it's just emphasising that we have to understand the terrain to understand the gold deposits. The gold, so what happens normally in any orogenic belt is we get extension, so we form the lavas. Then those faults get reactivated. Eventually things start colliding back on themselves. We close up the extensional basin with a series of thrusts. We might put some intrusions in at that stage. We then deform this and we get upright folding and shearing going on, and then at this very late stage we get this strike slip. So the subduction is happening this way. It's orthogonal. Whoops, sorry. This is orthogonal here, 90 degrees to the terrain. Then all of a sudden the angle changes and we get this oblique slip, and this is where we see all of our gold, and it's occurring very late in the orogenic cycle. So it's occurring right at the end of orogenesis, and this is, I'll show why this is important. Very complicated diagram, don't need to worry too much about it, but this is just showing that we can date. This is one of our terrains in Western Australia that I work on. Got the youngest rocks, so we look at the youngest rocks we can that host the gold. So the gold's got to be after that. Then we try and date the gold, which is very difficult here, and then we look at rocks that post-date it, dikes that cut across it. We can see we've sort of got a gold window in here. This was pretty poorly defined. This is some years ago. And since then we had a big project. A lady called Noreen Fioraika did a study, and she looked at 10 provinces over about 4 years, did very, very detailed geochronology, and all of the deposits occurred at about 2640 million years ago, as we predicted on this diagram. And by 2620 million years ago, so only 20 million years later, we effectively had cratonization. So everything had stopped, the craton had formed. So this is telling us that it's likely in Egypt that the gold formed very late in the cycle, just before everything completely cooled down, and nothing much happened after that, except for what's happening in the Red Sea and what's happening around the edges of the Mediterranean, for example. So what it means is this is the Golden Mile. I'll come back to this. Don't have to worry about these names. This is the Golden Mile in Kalgoorlie. What it means is, even though the terrain is 2.7 billion years old, most of the rocks, the gold is 2.64 billion years old. Even all the isotopic systems had closed by 2600 billion years old. So what it's telling us, when we look at a map like this, essentially that was the map. That's the map at the time the gold formed. But we look at a cross section. Nothing much has happened since that time. Now, this is very useful from an exploration point of view, because what it means is all the structures we see today are essentially the same as they were when the gold formed, because the gold is forming very, very late in the cycle. Tomorrow we'll hear, for example, that the volcanogenic massive sulfides are forming on the sea floor. So they're forming at this stage. Maybe some form at this stage, but it's contentious, but most of them are forming at this stage in here. So they get deformed by all these deformations. So I don't know much about the ones in Egypt, but looking at some of the papers on the ones in Eritrea, they're very, very strongly deformed and foliated and so on. And all the deformations occurring there is what is causing the gold deposits over here. So these gold deposits are always later than those. So we're seeing the geology at the time. The geology